All right, let's get started. Welcome to the session on identifying and fixing issues in code using AI-based tools. My name is Venkat Subramaniam. I want to talk a bit about using AI in general before we dive into this topic. So we are currently living in this frenzy of it's got to be everything is AI. And I find a lot of value in what AI provides, but at the same time, find it very frustrating as well. And I want to spend a few minutes talking about where I find it to be very useful and where I find it to be probably terrifying. I was in a gathering about a month or so ago, and somebody whom I don't know came to me and said, well, I heard you're a programmer. And he said, are you worried about losing your job? And that's a nice way to start a conversation. and I said, and then he said, what's your thoughts on AI? And my response to him was, when I use AI to ask it to do something that I'm a novice at, I'm in awe. I'm like, wow, look at what it did. But when I ask AI to do something that I'm an expert at, I feel absolutely disgusted. And it's really funny because when you look at the solutions it can produce, you're like, that's not what I would have any of my developers ever create code like that, for example. So I find that AI's ability to write code today is not quite at the best, in my opinion. People get excited about it, and I think they have the right to do so. But I think the code that AI generates is a fairly good prototype. It's something we can experiment with. We can use it to illustrate how something would work. But at the same time, though, I'm not comfortable pushing the code AI generates to production, just not yet. And I often say that here's my current recommendation in terms of how do we go about using AI. And I often say that use AI to generate ideas and not solutions. This is my current recommendation. The reason is, to me, ideas are extremely valuable. And if I get 7 or 8 or 9 different ideas, then I can ideate on them and say, which one of those maybe I should focus on a little bit more. And then I can decide on what the solution should be. This is what typically we do in teams of developers as well. When you work with teams of developers, you're not rushing to a solution. You're asking your team, what are different possibilities? What are your thoughts? What do you think? And pros and cons, why should we do this? And so on. So if you ask me, is AI super good? And I would say it depends on what you are asking it to do. So if I'm asking AI to generate code, I would say as of today, I'm not too pleased with it. It's a great prototype. It's a nice experiment, but not something I would comfortably ship at this point. However, there is an area where I think AI is actually pretty darn good. But this also resonates really well with myself. And I think a lot of us are like that. I'm not alone in this. And it took me a while to realize this. And what I found out was I am really terrible at writing code. And you're going to say, oh my gosh, you give all these talks. I'll be honest about it. If you ever look at my code, you'll be in shock. You're going to say, oh my goodness, we cannot believe that's a code you're writing. So I'll admit to you, I write terrible code. But what I found was, while I write terrible code, I'm extremely good in finding fault with other people's code. And that is my superpower. So I realized, rather than pretending I can write good code, I write the code I can, and while I review somebody else's code and kick and scream and complain about it, they take the turn to do the same thing about my code, and we end up developing a better code together. But I find, ironically, AI is similar to that as well. I think AI is terrible in writing code, but it's really good at finding fault with the code that you present to it. The irony is this. When I ask AI to generate code, it generates some rubbish, and I'm like, seriously? And I literally take the very code AI generated, feed it right back to AI and say, what's wrong? And it gives me a list of things that's wrong with it. It's like, duh, right? Why can't you then figure out to not write that code, right? So I think this is an area where I think we can really leverage AI because it's really good in identifying problems with the code. And typically, what is the situation we end up with? Most of us have the issue that we are thrown into a piece of code, either we didn't write or we don't remember writing. And as a result, you're trying to understand what this code is actually doing. Or somebody is calling you with a problem potentially in production. Or somebody is asking you, hey, is this production ready? How do you comfortably say this is going to work or there are hidden problems in it? Well, if a tool can give you a list of things potentially wrong in it, not that all of that are really concerns you need to address, but if it gives you a list of things to be concerned about, that is enough for us to investigate and see maybe these are things we should be concerned about and maybe we should fix them as well. And that's what I want to focus on today, is how can we leverage AI to do that. So there are, of course, several tools, and before even I complete that sentence, there are more tools that have been introduced. And so you keep chasing these different tools, and this is one of the things I've realized as well. I absolutely had a luxury about a month ago to do training where we literally had about 100 people online. So that's a large group for you to try things with. So I gave a set of problems to this large group of about 100 developers, and I told them, you should use whatever tool you want to use, but you got to report back what your findings are and the tool you are using. So when I gave the first problem, people started reporting, oh, this tool is amazing, and this one is not as good. But at the end of the training session, we all agreed that every tool is good, and every tool sucks at the same time. So not one tool really stood out. There were certain problems for which a certain AI tool was better, and certain problems where the same tool did not really do as well, but another tool gave a response. Part of the reason for this is we tend to, in our field, I think, we really are very good in giving ridiculously wrong names for things. Think of NoSQL. Why would you ever call it NoSQL when you actually have SQL? Or why call it wireless? Why call it less of what you don't have? This kind of blows my mind, right? Or you tell the kids it's a cordless, and they're like, what is a cord in the first place? Why less of it? So we really have a hard time naming things. And that's one of the problems with AI. We call it artificial intelligence, but there's no intelligence in it. And that is the problem with the name. So I call it an accelerated inference. That's what it really is doing. It's a very accelerated inference. This is what we do as humans too, is we infer things based on the knowledge in front of us. And AI is trying to infer based on the wide knowledge it's been given to it, and not that the inference is always correct or always good or even better. And whatever inference it comes up with, this is where you can keep hitting the refresh and saying, give me the next one, give me the next one, until maybe you get to something more satisfactory. So this is the reason why things are not very consistent. And so it's no surprise when you are giving it different problems over time, it's not going to give you a consistent response. So tools vary in their measurement of are they good versus are they not good. So we need to really try different tools as well. So we talked about the benefits and the drawbacks of using them. But let's step back for a minute and let's answer a couple of questions here. So I'm going to ask the question, what are some of the common errors that creep into code? And I'm not putting you on the spot right now, but I want you to just blurt out a few things that come to your mind. So fire away. What are the common errors that creep into code? We're like, oh my gosh, look at that. We didn't realize we made this mistake in the code. What are some of those that come to mind? Off by one error, right? So off by one. Awesome. Cool. What was that? A null pointer exception. Null pointer exception is special, right? I have a good friend of mine. After giving a talk in a conference the entire day, he decided to relax in his hotel. He turns on the TV, and it threw a null pointer exception on him. I mean, forget about horror movies, right? If your TV is going to misbehave like that, so it can be really problematic. So absolutely, we got to be really careful about it as well. What else can we think of? try and catch, and so many things that go wrong with it, right? So we won't even want to go into that, absolutely, yeah? A poor error exception handling, let's put it that way, right? So a poor, we could say, exception handling. What else can we think of? Duplicate code. Okay. What was that? I'm sorry, I couldn't hear that. Oh, cast. Okay, thank you. Exceptions, cool. Oh, leak of resources. So we can keep looking at these, right? So awesome. So we are trying to think through these and identify what the problems could be. Let's just post that question here, and I'm posting that into ChatGPT. While it's doing that, let's go to Claude as well and post the same question. And let's switch back here and see. Syntax errors, I'm not really thrilled about it. Runtime errors, it's got a division by 0, null, and type mismatch. Logic errors, well, that's, actually, this is something I've actually seen in production code. And it scares the daylights out of you when you see the code sitting there and it's in production and nobody ever noticed it, right? And you're the new guy on the project and you're like, excuse me, is that supposed to be here, right? So that's really interesting. Class mentioned off by one error right there, absolutely. Wrong algorithm. Semantic errors, it says, and we see quite a few of those in code as well. Common specific examples. And so it gave a few things. Today, it's not a great day. Maybe it is nice weather outside. It's outside and not focused on this. So usually it gives me a much better results. So here is Claude telling us the logic errors, syntax errors, runtime errors. Very similar resource management errors, like somebody mentioned a few minutes ago. Invalid input validation errors, SQL injection errors, buffer overflow, type conversion errors, you mentioned it, edge case errors, as you can see. So I have to say I'm a little bit disappointed today because usually this list is about 3 times the list when I ask for it. It's just a little shy in front of all the people here. So I'll do this privately in my office. Maybe it'll work a lot better, right? But the point is, we could list some of these using different tools, and we can collate all of that and take a look at things maybe we can look at and look at a checklist, so that could be useful as well. Okay, so that's great, but let's switch gears and see how effective the tool could actually be in looking at some of these examples. So let's take a look at one example here, and before I go into this example, let me mention this. The code I'm about to show you right now is an example code, but a similar code in production that did something very critical with financial data. Somebody emailed me and said, the email started like this. The email said, hey, Venkat, this code worked fine until yesterday. And I made one change, and all hell broke loose this morning. What did I do wrong? That was the question that was asked of me. So the code I'm going to show you here is going to have that one change. Let's see if any tool is able to find that for us. So here's the code. I want you to think about this for a couple of minutes, if you will. So here is the code. So we have a collection of names coming in here, strings. And I have an array list that's going to have the result. So we take the strings, we go through a stream, we convert them all to uppercase. Then we check if the length is equal to 5. And if it is, we are adding that string converted to uppercase into that result that you created up here. And then we are returning the result back from this call. So the question is, and I got a little example here of a bunch of fruits, and I'm calling that code with it. So the question is, what are the issues in this code is the question. So I'm going to just pause for a minute. Before we ask AI, let's think about this. Anything comes to your mind, things that could be a problem in this code? Please. If I do what now? A null? Oh, yeah, so a null could be a problem. Null is always a problem, right? Because there are some developers sitting there thinking, don't want anyone to be happy today, and then passes null around. So absolutely, you have to protect yourselves against null. What else can we think of? A mutation. Aha, she nailed it. So when you look at this line number 10, you have a side effect on that code. So when you're writing a functional style code, you should avoid side effects. Now, obviously, somebody is going to look at this code and say, it works. Well, unfortunately, you cannot run a piece of code and see the result and claim that it actually works. That's a bit of a stretch, because a code may or may not work. You can say the code behaves, but saying it works is a bit of a stretch. Let's take a look at why that could be a problem really quickly here. Now, in this particular given code, that may really not be an issue, you could argue, right? So you could say, hey, this is not a big deal. The code is going to just be fine. I don't have to worry about it. But let's take a look at what could potentially go wrong in this particular code. So I'm going to take this code, which is a sample sitting right here, and I'm going to simply just run that code. That's all I'm going to do right now. And let's see what's going to happen, right? So essentially, in this particular case, it gave you that, all these values, and it said 7, right? So obviously, that's quite fine. And we could potentially run this many, many times here on the command line, and we can take a look at it. And again, I cannot guarantee anything right now, because it depends on if the demo gods are willing to work with me today. But it's giving us the same result. Shouldn't be a problem. So you may argue, why should we be concerned about this code, right? So yeah, we are making a side effect. We're mutating. So what? What did this developer do that morning that messed up everything? That's right. The developer converted it into a parallel stream. That's exactly what the developer did. And the developer converted it to a parallel stream in the application that the person was working with. Now, when you convert to a parallel stream, what could potentially go wrong is the question, right? So you can see the result is no longer consistent. It is a 7 right there, but occasionally it's a 6. If you're lucky, it's going to misbehave on your machine. If you're not so lucky, it'll wait until you go to production. So the problem here is, look at how inconsistent that code execution is. I call this a ticking time bomb. But a lot of developers may not have really observed that. Now, unfortunately, the person who writes that code may have quit 3 months ago. You, by the way, got hired. And if you really look at your offer letter, it clearly says your title is called victim, right? That's what you are, because this code is going to misbehave one night in production, and that's okay. But you are holding the call, right, for that night, and you get the call that something is really bad in production, and you got to go to work to fix it. So how do we identify these kinds of issues? And we can sit here and guess about it. But if a tool can help us to at least proactively detect this, wouldn't that be really nice, is the question. So let's go back again to a couple of tools and try that. And it says, the Java code appears mostly correct. How beautiful, right? Is that what you want to tell your customers? It works mostly, right? So, and then they say, we paid you mostly too, right? So that's not going to be fun. So it's mostly correct at the first glance, but it contains a subtle but significant issue related to concurrent modification of shared mutable data structure. Like she identified, it nails it. So it says the method, it goes on to talk about it. It uses parallel stream for performance. However, here's the key issue. Now, of course, if I don't put parallel in this code, right? So if I were to take the parallel out of this code, and still ask the same question in here. And I'll do that in just a minute. Let's just read through the rest of it. And then it says, a line in question, and it says that's a place where you're adding. Why is this bad? It explains to you the race condition, data corruption. And then the solution, it tells you what to do about it. and it says use collect collectors.toList, which I would argue is incorrect, because in more recent versions of Java, you can call toList directly on the stream. So this is the old code. This is what I was saying. I trust it to tell me what's wrong. I don't trust it to write code yet, right? So you need to always examine it. And it has a few other observations and recommendations as well. But I'm going to ask it with the stream without the parallel on it. And then, of course, in this case, the code works, but has a design flaw, and it tells you again misuse of the stream and is identifying that pretty good. So I think that's actually really nice. In fact, I would challenge you to do this. Take that code back to work and show it to your colleagues and see how many of them are able to find the problem in that code. And I would bet you maybe about 20% of developers are able to find the problem in the code. And most of other people are going to just stare at it and not realize it, because we all have written code like that. So, but on the other hand, when you feed that into the AI tool, it can identify the problems for you and show you what's really wrong with it. That can be extremely powerful, as you can see in this particular case. So in here, what does it say? When you give this code, it says primary issue is race condition and parallel stream. And then, of course, it says incorrect stream terminal operation. So that's not a good idea. You should really use a toList, it says. Again, it's using an older version of Java in this case. And predictability issues and so on. Well, obviously, because it's parallel, the sequence is not guaranteed. But I'm going to ask it again without the parallel in this particular case. So I'm using a stream, as you can see. And in this case, let's see what it is telling us. So again, looking at the updated Java code, the critical case issue from this has been fixed by switching to, OK, but it's going to come back the minute you change it back to parallel. It should really be able to identify that as well. So again, this is the area where I would argue the tools are really helpful if it's able to identify these kinds of problems for us, and we can leverage that really nicely. Well, OK, so let's go a little further with this. Here is my next example that I want to pull in, and let's take a look at what we notice in this one. So I have a convert to upper if length 5. And in this, we say if the length is 5, the string is string.to uppercase. Otherwise, string is equal to null. And return the string. And again, it's just exercising the code. What is the issue in this code? Anyone wants to say, what could be the problem in this code? A null pointer exception for the caller, right? So one of the problems in this code is it fails the principle that we should program with intention. So when you're looking at the code, it is not making the intention clear that sometimes you may have a result, sometimes you may not have the result. So it burdens the user of your code that they have to check for null, and if they don't, it's going to blow up at runtime on their face. So there's a better way to write this code. What would that be? What was that? Pass by reference. That generally may not be a good practice, because I'm not a fan of mutating an input given to a function. What else could we do? Optional, right? So you could use optional to convey that this may or may not exist. So let's see if any of the tools we are using is able to identify that in here. So let's go over to the question here. Let's ask it what's wrong with this code. And let's go back here as well. And let's go ahead and ask it again what's wrong with that code as well. And let's see if it's able to identify any of those. So it is telling us response, and it is giving us a, so here is the functional style. Well, actually, it's not functional style. It's just an imperative if in this case. Let's see. The code you provided is functionally correct and will compile and run as executed. However, there's a few issues in it. So in this case, it says null pointer exception, potentially a problem. And the method name could be more descriptive, which is saying convert to uppercase if length 5, use a reassignment minor, and it says you're reassigning to a variable. That, again, is a very poor programming practice, right? Because if you're taking an input parameter given, and if you're modifying it, that's terrible practice, and languages should generally not allow it. In languages that don't prevent us from doing it, we should have the wisdom not to do it. So that's a very poorly written code. But that's able to identify that as well and says, hey, why are you reassigning that variable? Instead, you could just return from that rather than reassigning that variable. So kudos for that. If null is passed in, you're going to have a problem with it as well. But what is the suggested improvement? I'm not thrilled about the suggested improvement in this case because it's not suggesting optional. I would have expected it to suggest optional. In this case, in response 2 that you see here, it is giving us a few more things as well. Null pointer exception again. It is telling a no null check in input. Unnecessary reassignment, so it nails that as well. And the readability as is. Again, I'm a bit disappointed. Oh, there it is. Finally, some sign of that. Would you like a revision that uses optional string instead of a safer? That's pretty good, isn't it? So it's giving you these ideas to say, maybe you should consider using optional. And I think that's really valuable because it doesn't matter how good we are. We're not going to think of all possibilities all the time. And if a tool is able to recommend some solutions, you're like, oh, wait a minute, that's a good idea. I can maybe explore and see if I should really use optional. So that's actually a reasonable solution. Again, in the case of Claude, it's telling us poor null handling, lack of input validation, totally. Actually, it kind of falls flat. I'm a little surprised in this case. It's not telling us to use optional in this particular case. It didn't quite call out on the reassignment, but it did rework the code to return instead of reassigning it. But I'm a bit disappointed it did not specify optional in this case. Again, I want to emphasize, don't take this as a judgment on one tool versus another, because the tools are never consistent. There are times when it will tell me to use optional as the very first thing. Today is a day it doesn't want to make that recommendation for me. If I try it again, maybe it'll tell me to use optional. That's why I call it it's really an inference, and it infers something, may not be the best thing it infers in this particular case. It says Claude does not have the ability to run the code it generates yet. Well, OK, that's fine. So not a big deal. So that, again, is we identified that the issue. We identified option may be better, but at least we can use a tool that can consistently, among the different tools we use, consistently gather a set of things to investigate. That would be really useful as well. OK, so here is one more thing that I have here. And this happens quite often for us because we're often thrown to fix bugs in code, but you may not have written that code. Or the colleague that wrote the code may have left the company already. And you're staring at a piece of code, and now you're required to understand what the code is doing. Now, we all know one famous technique to understand what a code is doing, right? You start debugging through the code. But that is the lowest point in programming, right? So you get tired, and you have to step through the code, and it's very frustrating, especially when you have to fix a bug fairly quickly. This is an area where I think really a tool can help us a great deal if it can point out to potential problems in the code. So this is an example code I have here for checking. If you know the game of Wordle, game of Wordle is where they select a word, and you're going to guess the word that they have selected. And depending on how you're guessing the word, they may give you different color-coded feedback, whether you got the letter in the right position, or you got any letter at all, or you did not even have a letter in the original word. So here is a piece of code that returns a check to compare the given word with the guess word, and it creates a little, with all the white spaces in it, with W's in here, and then here's the given word. We are putting that into a string builder, and then we are looking for the exact matches, and then the non-exact matches, and then we are returning the result. And then G is a green, Again, if you know Wordle, you know what green means. It's an exact match. Y is for yellow, non-positional match, and white is a non-match. So essentially, we have these words we are comparing, and the question is, what's wrong with this particular code? Anyone sees the problem in this code? What was that again? Line number 9, what happened there? It should be a dot equals. Okay, cool. What else? What check is there? Null check, you are saying? Oh, like checks. Oh, okay. So if the word is to input validation, if the word is too short, maybe you need to check for it. Anything else? I often say there's not enough sugar in the tea problem when the building is on fire, right? So yes, you're right, but there's a bigger issue here. If the word contains a duplicated letter and the original doesn't have duplicated letter, this is going to get it wrong. So there's a logical bug in this code. And that's not easy to know unless you sit there and scratch your head and think through the problem. I've played this exercise with a number of developers where I asked them to write the code, and invariably they will write the code with the bug actually, because they're not thinking through the point that the letters may be duplicated in the guess, but they may not be duplicated in the word, or vice versa. So something to really look for in terms of the logical error, you may want to really think about it as well. So let's go back here and ask the question and see if it's able to find it. So I'm saying, what's the problem here? It says a functional goal recap. G is for correct letters, Y is for wrong position, but there's a match. Letter is not in the word. And then it goes on to say that issues in your code, yellow logic does not account for letter count or prior usage. It nailed it, as you can see, right? So it's able to find out the bug absolutely instantaneously when you give it the code. That's what I love about the ability to nail the bugs in code. A couple of weeks ago, I was looking at some code, and we were writing unit tests for a piece of code that already was there. And I took the code and I said, forget it, I'm just going to see what the AI tells me. And it actually was able to find a few bugs in the code we did not even realize was there. So to me, that is very valuable if we can find the bugs in code pretty quickly. So this does not account for when a letter is duplicated, and the correct behavior should ensure, and it is telling you, and then overwrites the green with yellow. That's another bug as well. And then misleading and incomplete logic for duplicates. So it's pretty much dealing with it. It gives you a fixed implementation, which is nice to have. But I would argue, be careful using the solutions again. And also, I'm a big fan of a functional style solution. I would rather spend some time implementing this code in functional style. I do have to say, I have not found an AI tool yet that can write the functional style code in a nice way. It took me about 30, 40 minutes to figure out a solution to write it in functional style, but none of the AI tools have been able to write that code yet. So, and I'm not showing it my code yet as well. So I don't want it to learn from my code just yet. So I've been kind of posing the challenge, and it's still failing. It's not able to write functional style code. So incorrect handling of non-exact matches, again, Claude is able to identify that as well. Non-exact match loop doesn't check the return result status, and guessing word with repeated letters, so on and on, it's able to really nicely find that as well. So pretty good in my opinion in terms of identifying the bug. And this is one area where I found it to be fairly useful, is detecting these kinds of errors in code. And it's nice when it's able to find these cases, sometimes edge cases as well, and be able to tell you where it potentially is broken. So awesome. So we saw a few different examples with a bit more complexity built into it. Now let me pause here for a minute, and then I will mention one other experience I had. I was a bit curious. The tool is able to identify these errors. It's able to tell me a little bit about what the code is doing. And so I was a bit curious, and I said, what if I make the code absolutely terrible? Now, I told you in the beginning that I naturally write terrible code, but I really turned it up very many notches. I removed every context you can find from the code. It was very painful. I had to take a few pills to really do this. And I made all the function names completely ridiculous. I call functions as foo and bar and nothing related to domain at all. I made sure all the variable names were single letter in their names. And then I made sure the loops were all in jumbled up order. So I made it really impossible for any human to ever find out what this code was doing. And I was mentioning I was teaching a group of about 100 recently. So I just unleashed this code on that large group and said, tell me what this code is doing. Not a single human, I'm assuming all of them are human, not a single human was able to tell me what the code was doing. They all kind of came in with their hands up and saying, okay, this code is absolutely terrible. We have never seen a code as worse written as this one. I'm like, yes, so this is good. And then we fed this code into AI and asked what the code is doing. And I was so delighted to see that AI couldn't figure it out as well. So, however, there was one difference between the humans and the AI. The humans gave up. They said, we don't have a clue. We have absolutely no idea what this code is doing. But AI said, this code is complex. We're not sure. And then it said, I think it belongs to this domain. So it couldn't tell what the problem was, but it was pointing to a little spear of, I think the solution belongs in this area. And I thought that was pretty darn good for it to even be able to detect in which direction to look at, whereas humans couldn't even go any closer to it. The AI was able to point out, I think it is kind of this problem, but I'm not sure, was the response. So that again, to me, where I pushed it to that extreme, the tool is still trying to hold up when the humans have given up at that point. I think there's a bit of a value to it, if you will, for us to consider. So let's go back to one more problem and take a look at it. Let's see if we are able to find what the problem here is. So this is a currency converter, and I have a public int convert from NOK to USD cents, and I have a NOK and a commission in percent. And then I have a low-cost currency converter, extends currency converter, and it says convert from NOK to USD cent, int NOK, and double fractional commission in percent. Anyone can see what the problem in this code is? A little louder, please. Yeah, so they're double instead of int, so what could be the problem because of that, though? It's overloading, but overloading requires the code to be in the same scope. So this is technically not overloading. But your observation is not wrong, but technically this is not overloading. But what could be the problem, though? So had I used @override, I will get a compilation error because the function in the derived is not overloading the function in the base. The problem in this code is that when you have a base method and you have a derived method and the signature is different as the type is different, this is a quite troubling code. Because if you use so here's the deal, right? Let's understand the problem you're going to run into. So if you have a base reference, let's say base b equal to new derived versus derived d equal to new derived, the instance is exactly the same instance in both the cases, right? So the instance is a derived instance in both the cases, no difference. But if you say b dot call whatever that function is versus d dot call whatever the function is, you will end up actually going to two different functions in this case. When you use a base reference, you end up with a base function, if based on the type. And when you use the same type, because of type conversion, it would end up in the derived function when you use a derived reference. If you think that this cannot happen, just as an example, if you look at a collection in Java, and when you look at a collection, and if you take a look at the remove function, and you have a list which is, of course, extends from collection, and there's a remove as well. Well, as it turns out, the collection in this case as an object, whereas in the derived, it's got an int index. Well, oops. If you create a collection, if you create a collection of integer, if you will, and then if you say, in this case, a reference, a equal to new array list of integer, if you will, and then if you were to say a list of integer one more time, this is a ref b equal to new array list of integer. Now when you call remove with a 1, you will end up actually calling two different methods, one on the base and one on the derived. So because the one gets auto-boxed to an object in one case, but it gets used as an integer in the other case. So this is an example in the JDK which actually has the same problem that the code example I showed you has. So this mistake is not unusual, or at least non-existent is probably a better word to use, and we all can end up with a problem like that. So let's see if our tools can actually nail that problem really well, maybe a bit more consistently in this particular case. So let's ask that question. So what does this tell us? It says method overloading versus overriding. So it's kind of pointing to, there's a bit of a confusion here between overloading and overriding. Missing at override, so it is able to nail that and says, had you used that, you'd have gotten an error, right? So that's a good recommendation. Code duplication, okay. And then magic number, okay, fine. So those, again, some of those may not be the most interesting or the most focused thing, but generally those are good things to pay attention to as well in the long run. But at least in the beginning, the first 2 points, it really is able to nail down the core issue that you need to be concerned with, is that you don't want to really change the type because you are actually shadowing the function, and that's not going to lead to a better design. So we definitely want to avoid this because it's going to be an inconsistent behavior because of the type and the casting. It may end up with a different function. So where it becomes a bit tricky, though, just as a quick pause, if you look at languages where, instead of polymorphism, if a language were to implement multi-methods, multi-methods, I often say, is polymorphism on steroids. Polymorphism looks at the type of the reference at runtime, but not the type of the parameters. Multi-methods will also include the type of the parameters at runtime as well. So if you take the same example and run it in languages that support multi-methods, Groovy is one example of that, then you're going to see a very different behavior. So this is not a terrible code to write in a language that supports multi-methods, but it's a terrible code to write in a language that supports polymorphism and not multi-methods. So that is something to think about and evaluate as well. But most of us don't use languages, at least with the intention of using multi-methods. So in this case, ChatGPT is telling us the method overloading, which is not overriding, so at least it's similar to the other one. Oh, a little bit more. It tells us we're violating Liskov substitution principle. Those of us who are a fan of solid principles, right? It lays out a description based on where we are violating a solid principle as well. I love that description. And a few other things, as we saw earlier as well, is pretty interesting to watch. So that brings us to the very last example I want to look at. And this one is a piece of code where I have a compute function with an n and a k, and then we have a double r and an int c. And then I have a loop that runs over here, And if divisible is false, and then I have a for loop, and then it has a divisible equals to true, and then it is doing that. So the question is, let me see if I can make this a little smaller so we can see the entire code. And so I hope that's still readable. No, readable as in you're able to see, not understand. So, so can anyone guess what this code is doing, actually? So it's not easy, right? You're like staring at this, and the first question I will also ask is this code even correct? That's one question, right? The second question is, what is it doing? It's got a math square root somewhere. How many of us were able to determine that it's computing prime numbers? That's hidden completely in it. So terribly written, right? It fails the slap principle as well. So this is I wish I could say this is a terrible code, but this is not an uncommon code in a lot of code I've seen. And developers just plow through it, and they write code. And I always ask the question, where were the adults when they were writing this code, right? And I've seen functions that run 7,000 lines long, and they're trying to debug that function. How do you deal with that? So it's not uncommon for us to run into code like that. So when you're trying to really understand code that you didn't write, but you're thrown into that project, what do? Let's just grab this code as it is, right? And just drop it in here and say, what's that code doing? And ask the question, and let's come back and take a look at it. It says it finds the first k prime numbers starting from n. That's pretty good, isn't it? So it's able to actually tell you what the code is doing when most of us in this room were really having a hard time. And again, it's not don't take it as a negative towards you. We're not supposed to do that because we are humans, right? We don't want to go through cognitive load. That's what the machines are for, to remove that burden from us. But to me, I wish I can tell you we will have a world of programmers who will always write good code. But by now, we know it's not going to happen, right? But at least we have a tool that says, I will stand up to the bad code and read it and tell you what the code is doing. I think that's a good relief for us to have. So it says it finds the first k prime number starting with n, and for these prime numbers, computes a square root and adds it to the running total. It returns a sum of the square root of the first bingo, right? It nails down what the code is actually doing. Except there's a bug in the code. We'll see if it tells us the bug or not. And then moving forward, step-by-step explanation, and then suggested Java documentation. So in this case, we are asking it to explain and document the code. That's what we are doing. And it says, do you want to optimize this, blah, blah, blah. So if you go back here to this code and take a look at it, what does this say? Well, here's the code we gave and ask it to analyze it. So let's see what it tells us with this particular code. And in this case, it tells us, I've analyzed the code, created documentation for it, and it says, starting to check from et cetera, it is giving a little bit more explanation on this one. And then I've created a comprehensive documentation that includes these things, so between 2 and itself. So a little bit long-winded, not as concise as the other one was in terms of telling us what the code is doing. But the code computes the first k prime numbers, starting with n, square root, and then it runs the sum. So it did find out what the code was doing and was able to tell us. I think that's actually pretty useful because a lot of times when you are thrown into a code you're not the author of, or a code that for a new company that you start working with, this can be huge benefit for us to find out what the code is doing. So we looked at a few different examples. In almost all the examples, I think it was able to pretty much nail down what the issues were. And like I mentioned in the beginning, I'm not a big fan of relying on AI right now for it to write code, but I've come to really appreciate it for finding issues in code, to explain what a code is doing, for finding bugs in code, and mostly when I look at multiple tools together, collectively the tools are doing a fairly good job. And this is an area where I am more comfortable using AI than any other thing in development. And I hope that was useful for your own journey as well. Thank you.